The other classification of welding process is gas welding process. Gas welding is a method of fusion welding in which a flame is used. We earlier saw a beam is used. Now, we are saying a flame is used. If you have a flame or if you want to generate a flame, there has to be a gas media which is there. So, it can be through plasma forming or it can be through set of gases which are mixing and you initiate the heat there. So, gas welding is a method of fusion welding in which a flame produced by combustion of gases to heat and melt the parental material and filler rod of a joint. So, we try to melt and we try to add copper to copper joining has to happen, we do by gas welding process. A filler metal may be added to the flowing molten metal to fill the cavity made during the end of preparation. Many different combinations of gases can be used to create the flame. It can be oxygen and acetylene, it can be oxygen and hydrogen, it can be air and acetylene. So, it is called as oxyacetylene flame, oxyhydrogen flame, air acetylene flame. So, you will have two cylinders, both the cylinders will be gushing the air. So, it comes through a nozzle. At the nozzle, what we do is we try to initiate a spark. So, then the flame starts. Moment the flame starts, then you try to heat the parental material, start filling the filler. So, you can see in the hand what he has is a filler rod. Brazing is done by this, gas welding brazing we do and many other processes we do. Oxyacetylene welding. Oxyacetylene welding derives heat from the combustion of a fuel gas acetylene in combination with oxygen. The acetylene mixed with oxygen when burnt under controlled atmosphere produces a large amount of heat using the giving high temperature rise. This burning also produces CO2 which helps in preventing oxidation of the metal during welding. So, ethylene plus oxygen giving you carbon dioxide plus water plus heat. So, this now becomes a protecting shielding layer, shielding gas. Oxyacetylene gas welding is accomplished by the melting the edge or surface to be joined by a gas flame and allowing the molten metal to flow through and thus forming a continuous joining. You can try to join as thick as up to 50 millimeter using this gas acetylene welding process. So, you will have a cylinder, then you will have one more cylinder. So, these two cylinders we try to take this cylinder. So, here before the welding torch, here you will try to have a mixing chamber. Where in which individually the flow of oxygen and flow of acetylene can be controlled. Once you can control it under pressure and here you can also try to do it, then after the mixing chamber you will have a gas flow rate controller. Through that you can try to control what should be the flow such that in the tip exit I will try to make a flame. So, here is a flame. So, here you will also have a flow control valve. Okay. A flame is obtained by ignition of oxygen and acetylene gas mixed in a blowpipe fitted with a nozzle of a suitable diameter. The flame is applied to the edge of the joint and the wire filler of appropriate metal to join them to form a part. The oxyacetylene flame can go up to 3000 degrees Celsius. As the melting point of the steel is appropriate 1300 degrees Celsius, the metal fuses rapidly at the point and the application of joint happens. So, there are different techniques. One is called as forward technique, the other one is called as backward technique. So, this is a forward technique. So, in forward technique, the weld starts at the right end and moves towards the left. directing the flame towards the unwelded joint. So, the flame towards the unwelded joint. So, right end and moves left, right. The progressively fed into the flame preheat base metal for proper fusion and suitable for metal under thickness of 5 millimeter. So, the torch angle is 60 degrees to 70 degrees. The filler rod angle is round about 30 to 40 degrees. So, filler rod is angle given, this angle is also given. So, this is joint. From rightward or backward, the weld starts from the left and move towards the right. The torch flame directs at the completed weld. So, the first one is something like a preheat. So, we can write it here. This is a preheat or a preheat of the previous one, and this is something like a post heat. Why is that post heat? Some defects or oxides or something has to be removed. It can be removed when we do in the backward technique. So, there are three types of flames. One is called as neutral flame, carburizing flame and oxidizing flame. Why are these things important? Because all these things have its heat which is getting generated, very important. So, and how do you make this neutral, carburizing and oxidizing? Based upon the compositional difference between the two gases which is filled. Neutral flame, when the ratio of the oxygen and acetylene are equal, the neutral flame is obtained. This type of flame has maximum temperature of about 3100 degrees Celsius, is white in color and has a sharp defined central cone with the reddish purple envelope. So, what we are trying to talk is something like this. You have an envelope, then you have a cone which is inside, and this will be the flame. So, this is the pipe or the hose or the nozzle. This is the flame. Okay. This is the center cone. And here we talk about the envelope. So, this is the envelope. It does not react chemically with the parental metal and protects it from oxidation, neutral. This is the cone and this is the complete flame envelope, right. So, here we say purple, here we say light blue, here we say bluish white. So, the neutral flame is used to weld mild steel, stainless steel, cast iron, copper and aluminium. When we talk about carburizing flame, an excess of acetylene is created for a carburizing flame. It consists of three zones: luminescent zone, feather zone and the outer envelope. So, you have seen the outer envelope. So, you have three zones. So, now basically what we do is we try to change this and the three zones such that you try to get the maximum temperature. It is also called as reducing flame. Carburizing flame is also called as reducing flame and has a maximum temperature somewhere close to 2900 degrees Celsius. The carburizing flame is used to weld molten metal, then it is also used for high carbon steel and alloy. So, here carbon, this carbon should not get diffused. So, once the carbon get diffused, it forms a highly brittle material. Oxidation flame, it occurs when the oxygen concentration is more than the acetylene. It is characterized by a purple white inner core with a purple environment. The maximum temperature is 3000 degrees Celsius. So, this is what it is. So, you can see how small is the whitish flame. So, you see the white flame, how it is broad, it is elongated, it is thin. Then you see the light blue flame occupying a larger area. Here it is thinner and then here it is much thinner. So, the purple environment you see here in the oxidizing flame, the purple is projecting for a long distance, and here you can see purple is very small, the light blue is dominating, and in this it is just touching with each other. So, now you know the temperatures, you know the flame characteristics. Now, you accordingly place your filler to get the melting whatever you want. So, the equipments, when we see, we have cylinders, the cylinders are attached with a regulator. These regulators are attached with a pressure gauge, because we have to know what is the cylinder pressure and regulate such that the gauge we know what is it there, then a weld torch, a hose pipe to fit the gas to the weld torch, and the safety device goggles. So, oxygen cylinders are painted black and the valve outlet are screwed right handed. This is very important because there are cylinders when you do oxygen flame gas shield welding. So, you will see cylinders, you have to identify which cylinder is what. So, oxygen is painted black and it has a right handed screw. The size of the oxygen is 3,400, it should be taller, 5,200 liters, 6,800 liters. The pressures are fitted with pressures of 12,500 to 14,000 kilonewtons per meter square. Acetylene cylinder, they are painted maroon and their valves are left handed. So, we are talking about only oxygen and acetylene, and here we saw three things: neutral, oxidation, carburizing. So, depending upon the composition. So, they are usually of a smaller height is small and they are up to 5,600 liters. The cylinders pressures are lower compared to oxygen, they are lower. Pressure regulators, they play an important role. So, you regulate the pressure such that you can, at the torch exit you get the flame. The pressure gauges are used to monitor the pressure. So, you have two pressure gauges are mounted on each cylinder, one for knowing the pressure of the gas inside the cylinder, which is measured as a gas content inside the cylinder. The second gauge is used to know the supply of the pressure which comes out. So, two gauges are there. Torch, we have seen there are two types of torch, high pressure torch and low pressure torch. High pressure torch, where blowpipe or torch are used with acetylene stored in the cylinder at a pressure of 8 bar. Low pressure, the blowpipes are used with acetylene obtained from an acetylene generator at a pressure of 200 mm head of water. So, you can have, interestingly today what we are talking about is these are gas cylinders we are having. Now, what we are trying to say is, we are trying to say let us generate, maybe you fill it with water, you fill it with some liquid and then you have a heat source. From here you generate acetylene. From in this you generate acetylene, that acetylene is used for joining. So, high pressure blowpipes are used with acetylene obtained from an acetylene generator. So, this is now a generator, these are heat sources or electrodes. So, this is a container, right? Acetylene is generated. So, you can use from a gas cylinder or from a generator. Hose pipe, these are all diameter fixed depending upon your requirements, and in welding we have already seen the welding shield will be used when we do arc welding. Here we have to use goggles because there will be spatter and that can hit your hands or eyes. So, you have to use the safety goggles. So, we use goggles for protecting our eyes, we use gloves for protecting our hand. Advantage, disadvantages are discussed in plenty. So, I leave it to you for studying. So, now the important terminology which comes is weldability. Can this material be machined, machinability? Can this material be castability? Can this material be forged, forgeability? So, can this material be weldability? It is defined as the capacity of a metal to be welded under the fabrication condition imposed in a specific suitable design structure and to perform satisfactorily the intended service is called as weldability. Weldability can be also determined, can also be known by determining a metal's behavior under fusion and cooling, by crack and notch sensitivity, or by comparing the heating and cooling effect which takes place at the joint of the metal with metal known for weldability. So, the factors affecting the weldability is going to be composition of the base metal, the thermal property of the metal, welding technique which we use, the filler material we use, the flux, when we talk about this, we have to put as mechanical property of the material. Or the heat leading to brittleness, the strength of at a very high temperature and the stability of micro constituents. So, all these things are factors which affect the weldability. Weldability is basically weld and be in the service condition in a comfortable position. So, the joints, there are different types of joints which are there. It is better we have some idea. So, this is called as the butt joint. If you see in solid state welding, we have always been talking about different types of butt joint, flash joint, they are all butt joints, right. This is butt. So, plate face to face. This is called as edge joint. So, flanging edges or placing where a weld must be made to connect the adjacent piece are ideal at the edges. So, this is edge, something like a book, right, but here you cannot open. The two metal pieces are there, on the top we do, this is edge, this is butt, this is edge. Lap, one sitting on the other, is called as lap. You decide which one you want. Larger the lap, larger the surface, higher will be the welding joint, but you can't keep on be lapping it because then you have a restriction. So, we try to have as minimum as possible, but to have sync. So, next is T joint. This also we discussed in the arc welding process. This is what I showed, a T joint. So, T joint, you will have perpendicular joint, a plate with a plate perpendicularly joining, and this is the weld bead. Then you can also have corner joint. A book is open, so a corner joint. So, this portion is joint. So, these are the normal used joints in welding. Depending upon the requirements, we try to do. Again, here if we closely see, there will be a surface like this. We do edge preparation. So, here this will be the welding happening. So, this portion we try to call root, and then here this we do it by edge preparation. This is a metal, this is metal. So, this is how it will be. So, same way here also you will try to have a trench like this. So, again this is called as a root, because between the two metal pieces the weld has to flow inside, right. So, these are the different types of joints, and most commonly used joints are there. This butt joint, lap joint and T joint, they are very, very common. So, plates are joined edge to edge is butt, two parallel plates joined on the top is called as edge, lap is one overlapping with the other, T joints are one at right angle, corner joints are at 90 degrees. So, it is plate perpendicular, this is plate 90 degrees. So, the positions, so it can be flat position, you can have flat position, you can have horizontal position, you can, these are also horizontal fixed position, you can have vertical position. So, you should understand welding is not done like this, welding is done like this, welding is done like this. So, flat position, right, horizontal position, all are possible. Then you can have vertical position, overhead positions, and then inclined positions. So, all these things are welding positions. So, you have to be very careful when we do welding operations. This is what is the edge preparation I have been time and again telling you. So, we have a V notch and then we have a flat portion. So, if you have a metal like this, between joint to joint you will never have perfect joining. So, we always do edge preparation. So, this is called as V preparation, this is called as U. You can also have something like double V, then double U, then you can have one flat and one beveled. So, you can have one flat and one U, then you can have one flat and double wedged, you can have one flat and double U, right. So, it is called as double J, single J, double J. So, all these things are done in the edges. You have a flat plate. So, what we do is we do edge preparation and then we try to get this surface. Edge preparation is very important. That will only, so what you see here is only joints, but between the surface plates you have to do this edge preparation. So, you can try to have square edge, single V, double V, single and double U, and edge preparation is possible. So, the next important thing which is commonly used in electronic industry is soldering. Soldering is an operation of joining two or more parts together by molten metal whose liquidus temperature is below 427 degrees Celsius. So, you have gun or you have a soldering rod. So, at the tip, this is a non-consumable electrode. You pass current and this portion gets heated. Now, you use a wire and then that wire is touched, the filler wire is touched by the gun, right, soldering rod, and that tries to melt the material you exactly place at the location where you want. It is a quick method of making joints in light articles made of steel, copper, brass or any other joints such as occurring in electric work. So soldering, this is how the entire setup looks like. So you have a soldering rod or a soldering gun, soldering rod. So inside a soldering rod you have all these things. Today it is also battery operated. So this is a wire, solder wire, which is made out of lead. So this, when it touches this two, this solder melts and they establish here, the weld establish a electrical connectivity. So connecting of wireless sets, TV sets, drain water gutters, pipes, radiation brass tubes for motor cars, and it is also used for repairing utensils. The solder joints are not suitable for very high temperature because it melts and the mechanical strength is also poor. So in electronics, we don't do tensile test. So it is all connecting together and it is placed there. So bracing, soldering is at a lower temperature, bracing is at a higher temperature. Bracing is a soldering method using brass as a joining media. Here the temperature is above 450 degrees Celsius. Dissimilar metals can be joined. It is considered as hard solder because the joint is stronger than the normal material. The brass is used in bracing called splutter, has a lower melting point than the base material for compatibility. So that is why this bracing process, brass leading to bracing. So the alloy composition, you can have copper 70%, 60%, 50%. Accordingly, zinc changes. Accordingly, you see a variation in the melting point. So much of heat has to be applied. So in bracing process, we use a flame. Generally, we use a flame. But in soldering process, we use a soldering rod, where in which the current is passed and it is not a very high current. It is only heating it and then this melts. So the bicycle frames are done by bracing. Pipe joints, exhaust pipes, band saws and tipped tools are all braced. For example, in cutting tool, tungsten is braced on top of a holder. So this is soldering, this is bracing and this is welding. So I am trying to compare. So this is used in electronics, this is used in inserts, and this is used in rest. So this is the difference between soldering, bracing and welding. So mechanism, it is all the three are adhesion. The temperature, you can see what is the difference. So filler material, it will be lead and tin, it will be copper and zinc, it will be copper, brass welding is copper, tin, bronze you can use. The joint properties are given here. All the soldering is majority of the time by capillary action. Bracing is also by capillary action. Capillary means there is a thin wall. So there is a negative pressure, the metal flows, sucks inside. Capillary action and you do it. So they are all used for different types of electronic applications. Now moving to the last part of the welding is defects which are happening in welding. So there are many defects because there is a heat, there is cooling, there is a residual stress component getting involved. So there is lot of defects which are generally possible in welding. So welding cracks are the major welding failures that occur as a planar fracture. You can see here the cracks. Planar fracture in the weld or base metal caused by a localized rupture from pressures, cooling, contraction and grain development in the heat affected zone. These cracks are stress concentrated cracks near the crack tip, making the weldment prone for failure. They are of various size, shape and type. The cracks can be longitudinal, transverse, crater, radiating and branching. So these are branching cracks. So there are different types of cracks which are possible. And depending upon the temperature, there can be a hot crack or a cold crack. What is a hot crack? The solidification crack occur due to high impurity or carbon content or disrupt heating flow during solidification is called as hot cracking. The liquefaction crack occurs from high heating temperature causing the liquefaction of a low melting point constituent. So this is called as liquefaction crack. Solidification flowing, it does not, there are impurities, then solidification happens. Cold cracking are delayed defects that form after solidification. This is during solidification is hot, after solidification is cold. So, these cracks can cause are caused by factors like lack of preheating, high stress, low temperature, high carbon content and material susceptibility. So, these are all the possibility for the defects to happen. Causes for weld cracks: poor ductility, combining higher welding speeds with low current, high residual stress solidification, lack of preheating before solidification, high content of sulfur, using hydrogen as shielding gas, excessive joint restraint, improper depth to height ratio, incorrect combustible selection of filler or flame. So, all these things are cause for various types of weld cracks. Weld cracks, as friends, you know, it can happen in the longitudinal direction, in the transverse direction. Longitudinal is this, along this direction. In the transverse direction, it can be a radiating crack, it can be a branching crack. So, it is a combination of the process, choice of material and filler. Prevention of these weld cracks, you have to use proper compatible filler, because the filler, whatever you use, if it solidifies faster, then it is getting attached to the base material, then it is improper welding happening and there will be a crack. So, we have to find out a compatibility wherein which the viscosity of the liquid which flows comes in contacts. When it contracts, it also tries to take the base material along with it. It will not be shrinking so much, but taking them along. So, it is use compatible filler material and weld process, ensuring clean base. Then use right welding speed and current. Then preheat the base, because you are playing with the wettability, cooling speed. Then use of sulfur content has to be reduced in the base. Gaps which are used in welding, arc length, that has to be maintained. Depth to weight ratio is important. Avoid hydrogen as a shielding gas for stainless steels. So, these are called as crater cracks. Craters are crater-like cracks that usually follow the arc ending near the end of the weld bead. Usually occurred after the welding process, but before the welding joint is entirely formed, this crater are formed. It is often occurred due to improper filling of the crater before the breaking of the arc. So, at the end it happens before. Basically, why does it happen? There is a solidification phenomena happening. When the solidification phenomena happen, the liquid tries to move, right. Once it tries to move, then there has to be enough of material to fill up. So, if there is not much of enough of material, then it creates a crater. This leads to a faster cooling at the outer edge of than the crater. So, insufficient volume of the weld may prevent this to occur, resulting in a crater crack formation. So, ensure filling proper, then you should also try to have an welding angle of the stick angle and other things. Use of small electrodes maintaining 45 degrees important. Gradually reduce weld current and also occur the welding technique. Undercut is also another major defect. Defect are irregular grooves formed in the shape of notch on the base material. They occur due to melting of the base of the metal away from the weld zone and are characterized based on the length, depth and sharpness. So, this is undercurrent. So, there can be three types: continuous undercurrent, inter-run undercurrent and intermediate undercurrent. So, this is undercut current. So, there are three types of undercuts: continuous undercut, inter-run undercut, intermediate undercut. So, these are the causes: high voltage, fast speed leading to undercut. Wrong electrode angle is also one of the major thing. When we try, then porosities, it is the same like what we had in casting, also known as warm hole weld. Porosity defects occur when there are entrapments of air and the other gas bubbles in the weld zone. So, during the welding process, hydrogen, carbon dioxide, steam are generated, that has to be avoided. So, the cross section of the porous weld bead often resembles a sponge with an accumulation of trapped air bubble. So, there can be gas porous, wormholes, and there are surface porosity. Gas porosity are small, spherical, and they are generated from trapped gases. It includes surface pores, elongated cavities, and linear porosity. When we talk about wormholes, they are elongated and tubular cavities. Gas is spherical, worm is tubular. Surface is everything comes to the surface, that breaks the surface of the weld is surface porosity. Again, the prevention can be suitable electrode, filler, and cleaning. These are spatters. Spatters are metal getting exploded and expelled from the place. Spatter consists of metal particles expelled from the weld arc, commonly formed as arc, gas, and track welding process. It is very common in MIG welding and typically along the weld bead and the welding joint. So, right polarity, proper shielding, increase in electrode angle, and cleaning the metal surface are important. So, the other defect is overlap. A weld overlap is a defect where the filler metal at the weld toe covers the metal without bonding. So, it just covers, overlaps, there is no bonding. So, it can be removed very fast. Okay. So, in this case the weld pool flows excessively and extend beyond the toe. So, many a times because it overlaps, it can be removed like a lug, slug, it can be removed like a slug. So, this portion itself can come out. So, this is overlap. So, these are the preventive actions which we have to take. Again, there can be a process parameter related matter, there can be filler related, or there can be any preparation of the metals which are to be joined, and then it can be the microstructure. So, if you try to do all these things, when we talk about this process parameter, it can be current, it can be voltage, it can be gas, it can be angle, all these things can be there. And filler, most probably it goes for composition. Preparation is basically cleaning. Right. So, it is very common for all the defects. If you do a proper of this, it can be done. So, there are lamellar tearing. So, these are lamellar tearing. So, lamellar tearing occurs in welded steel plates, causing the terraced cracks due to thermal contraction, often parallel to the weld fusion boundary. Lamellar crack occurs in welded steel plates, causing traced cracks due to thermal conductivity, often parallel to the fused weld boundaries. So, this can be prevented by ensuring welding is done at the end of the fabrication. You try to do it, because thermal contraction plays a very important role. These are slags which happen. These slags can happen because of oxidation formation or the other impurities which are there. The slags formed when the flux melts during welding, creating byproducts on the weld surface within the weld. So, these are the causes for the slags. I am not going in depth, so I would request you to go through it reading. So, preventing of slag inclusions are also discussed. So, there can be incomplete fusion. So, the weld edge preparation is done, the welding is done, but the weld material is not completely filled. So, as known as lack of fusion, this weld defect occurs due to inaccurate welding that results in unfilled gaps. So, weld roots has to be created such that it can be done a proper fusion. So, again what are the causes for incomplete fusion and the prevention of incomplete fusion? So, there can be a possibility of incomplete penetration also. So, when we do edge preparation, if the gap is too small and the air gets locked in it, so this air tries to prevent the weld metal to flow, that is called as incomplete penetration. In welding, penetration is the distance from the upper surface to the base to the maximum weld extent. Incomplete penetration occurs when the metal grooves is too narrow and it is not filled. As a result, the weld metal does not entirely spread in the joining region. So, that is incomplete penetration. So, what are the causes? How do you prevent it? Because of heat, there can be a distortion. Distortion or wrapping arises from the excessive heat applied during the welding, leading to the change in the position on the dimension of the metal. So, how do you avoid it? You try to have a combination proper and try to apply process parameters proper. There can be 4 types of distortion: angular distortion, longitudinal, fillet and neutral axis. So, these are burn through. In the application of excessive heat during welding, the process may blow hole. Many blowholes through the center of the metal can happen because excessive heat. So, there can be vaporization and the metal viscosity is very low. So, it spreads very fast. The process may blow holes through the center of the weld. This type of weld can be called as burn through. Again, the cause, the prevention. So, friends, I am not going deeper into it because these are all self-learning. I would request you to go through. So, the mechanical damage is because of the clamping. Whatever you do, there can be an indentation or damage. So, that is called as mechanical damage. So, you make sure that when you put a clip where the circuit is complete, the force is less. So, incorrect holding and other things are there. So, looking into all these defects. So, now there are also non-destructive testing methods which can be used in forging process as well as in casting process. Several of the non-destructive testing techniques are available today to find out the defects, the flaws which are there. Why are we doing non-destructive? Because we wanted to evaluate the strength, the durability and the performance of the weld strength by looking into the response from the non-destructive testing. So, NDT is essentially used to weld integrity, especially under severe load conditions. So, there are need for destructive testing, replacement or discarding these pieces will happen. So, the internal flaw is weld, so helps to avoid failure. So, destructive is you join, you destruct it and see, but that is costly. So, now we are trying to do a lot of non-destructive testing ways of inspecting the surface. So, these are some of the non-destructive techniques which are used. Visual inspection can be thought of. Liquid penetration is you pour a liquid and then you pour one more liquid. So, wherever there is a so you have a liquid which is smeared on top of a surface, you have a developer which is added. Wherever there is overflow of liquid, so there you can see very prominently the development will not happen, rest of the places it will happen. The ultrasonic which we use for welding, we use an ultrasonic piezo actuator to generate a signal, pass through the weld joint and collect the signal back. So, we try to evaluate. Thermography is also one of the most popular non-destructive testing way. Radiography is X-ray taking like human we do, and eddy current testing is we pass current and we try to see what is the response and where is the crack which are getting formed. So, I am here with giving you all the non-destructive methods which are exhaustively used in welding or in any manufacturing process, so that we try to evaluate the joining, the metal manufacturing process without damaging it. So, friends, in the complete welding lecture series, we have seen the introduction, history, advantage, limitations. Then we saw various welding processes like fusion welding, arc welding, gas welding, submerged arc welding, TIG welding, MIG welding, then friction welding, soldering, welding defects and inspection techniques in non-destructive testing way. So, these are some of the topics which we covered. I am sure the welding lecture would have been very exhaustive. You will try to capture more details, and the advantages, disadvantages and applications and prevention methods. These things I have led to for you to do a self reading, so that you can try to understand. When you prepare for the examination, you have to form a table, and with this table you will try to write down the parameters. So, you can try to read like this. So, these are the different processes P1, P2 electric, and then you can try to have condition, then you can try to have defects, whatever it is. So, by this way you will try to compare in a single table what are all the different processes, which one is used for what. These are the references which are exhaustively used. With that, I would like to thank you all for your patient listening. Thank you.